retype it, the same thing. Abs A minus B less than or equal to delta, and mass dot absolute B minus C less than equal to delta, and mass dot absolute A minus C less than equal to delta. Okay, so basically what this method is trying to do is trying to check if the 3 points are roughly on the same line. Okay, so you have 3 points, and then I want to check to see if those 3 points are roughly on the same line or not. Okay, so the next method is left gesture is basically getting the left shoulder point, elbow point, and the wrist point, and then we will compare them in some ways to be able to tell. I will not explain this code because it's quite straightforward. I think you can look at it and you should be able to understand yourself. Okay? So once we add that, these code are added, now we completed the gesture recognition for some static gestures. So let's try to run it and see if this works. Okay, so now we run it. Okay, so this is the code. Right now it doesn't recognize anything. As soon as it sees my whole body. Okay, so you can see that it's actually working because it's able to detect the various positions of your body based on the mathematical equations here. Okay, so that's how you actually do the static gestures. So now you're able to detect some static gestures. Let's go to a method to allow you to actually detect dynamic gestures. Okay, so what is dynamic gesture? Basically, dynamic gesture is basically a number of kind of gesture positions, a number of static positions over time, right? So to be able to, and you want to check to see if this set of positions over time confines to certain pattern and constraints. Okay, so to be able to do that, the first thing you need to do is you need to be able to record kind of a chunk of those skeleton positions over time, and then you can perform some analysis on the top of it to determine if it's any gestures or not. So here is how we can actually create a history for you to analyze into it. Okay, so we basically create a list. The list is actually composed of all the skeleton data. Okay, and then we create this list. In the variables we defined earlier, we call it skeleton history. Okay, and then basically we wanted to be able to save each frame into the history and check to see if the history contains a gesture or not. So this is the code that we will do to place in the skeleton frame ready method to replace the static gestures detection right here. So let me just comment this out and replace the code right here. So here you will see that basically what we want to do is we wanted to update the skeleton history with the data we have on each frame, and then we'll check if this data conforms to a wave gesture or not. And these are just basically I want to pass in some passing the two text boxes so that we can print out some debugging information. Okay, and then if it's true, we will basically tell you that it is waving. Okay, so we know that the two variables here is actually gesture left and gesture right. Okay, and then we will say that gesture left.text equal to weighted. Okay, and then we'll also copy the two methods. Okay, one is the update history, one is the weighting method. Let's copy that. And then we'll place that into the code. Okay, again, we notice some errors. We'll fix that later. But let's first explain this update history thing doing. So what this does is that it will, each time it's being called, it will add the last skeleton data into the skeleton history, and then it will check if the count is greater than 60. If it's greater than 60, it will remove the first one. So it only keeps about 60 frames. Okay. So the 60 frames depends on how fast your computer, can be either 2 seconds or 3 seconds. So since my computer is pretty slow, it's about 3 seconds. You can change this frame rate here to the time that you want to record the gesture to. Okay. So a better way is probably put a threshold. You can probably say that, you know, there's a constant int gesture time threshold equal to 60. Okay. And then in here, instead of calling 60, you just say gesture time threshold. Okay. So this way, it's probably a little bit cleaner. That's that's how you're going to define how long you're going to track a gesture for. Okay. So this is basically updating and checking the threshold, and here we like to check for the gestures. Basically, we have passing two text boxes here to allow you to print some to actually get out some debugging information. And what we do here is that we will create a copy of the gesture history. So we don't want to touch the original gesture history. We will create a copy of that. And then if the copies count is less than the indexes to check. So here what we check is that we want to check the gesture period equal to 2 seconds. And this is the index per second is 20 frames per second. So here we only checks if the local history count is more than 40. 2 times 20 is 40, right? If it's less than that count, we return false. We don't check. Okay. Then we get the reference distance between the spine joint position to the hip center position. So that's you can basically looking at the Da Vinci's kind of skeleton, and then figure out the distance is, right? So here there's some problem here I need to fix. So let me fix that first. So position dot y minus local skeleton history 0 joints and joint ID dot hip center dot position dot y. So because I copy paste from the web, there's some probably weird characters that make it didn't work. Okay, same thing happened here. I need to do a bit of fixing. Okay, so minus indexes to check plus 1 I less than less than local story dot count I plus plus. Okay, so I check if it's identical to this code. I can just remove this one. This has problems. It's probably this one. Okay, now it fixed the problem. Okay, so what it does here is that so this is check if there's enough data to check from. After that, we have enough data to check it from. What we want to see is that if everything in this, for each of the gesture frames here, if the right hand should be above the elbow, below the head, and the hand should be higher than the wrist. Okay, this is the constraint that I want to check. If this is not true, we will return. We will not go in any further. If it's true, then we'll see that if it's true, then we will move on. Okay, if it's not true, we will actually see the hand position is wrong and we'll return. Okay, and then we will set the. So after it's being checked, we know that the hand is in position. We'll show this debugging information, hand is in position. And then we will check to see if the hand has moved to the right. Okay, so basically this is to check if the local history, this point is greater than the starting position plus reference this and not move right. Okay, so basically this is saying that my hand has crossed certain position to the right. So it's beyond my starting position and move to the right. Okay, so if that's true, we will say it is moving to the right. And then what we do is that if the hand did move to the right, we would check to see if it returned near the origin. Okay, so this was checked that the hand did move to the right, and then this is checked to inside of the set of the data if anything has moved to the original position. Okay, if both of these are satisfied, then we will know, we will clear the history. Okay, and we'll say that okay, this gesture has been detected and it is true. Okay, otherwise we'll return false. So this is the basic simple structure of the algorithm to detect wave. It's not the perfect algorithm, but it works. So now let's demonstrate how it works. Okay. So this is the hand. Okay, it says put it up. You can see reading your hand position is wrong. And then if I put it up again, it should tell me that hand position is correct. The hand in position. And then if I can go back, let's say maybe if I move down again after about 2 seconds or 3 seconds, we'll say hand position wrong. I move it up, maybe. So it's not really perfect. So you can improve on that, but it shows the point. So basically this is how you can do a static gesture and the dynamic gesture using the Kinect library here. So because today's time is a little bit limited, so I will just produce this rough video and you can take a look at it, and if you have any questions, let me know. Maybe when we have time, we can produce a better video for you to study it in the future. Okay, thank you for listening. Bye-bye.